BSides DC 2016 videos are brought to you by clearedjobs.net and cybersecjobs.com, tools for your next career move, and Antietam Technologies, focusing on advanced cyber detection, analysis, and mitigation.
Hi everybody, thank you very much for being here. So normally it won't check like 2 minutes ago. I'm Pierre-Alexandre Bracken. I come from Montreal this morning. I flew this morning. I'm Belgium, and I will present you how to abuse Windows with tools that it installed and signed already in Windows. Yeah, sorry. Like that. So, like I said, I'm from Belgium. I'm working at Deloitte in Montreal. I do incident response, compromise assessment, and red team. I have 13 years experience in information technology and security. And I already talk at several security conferences like Hackfest, InfoSecurity Europe in London, UK, sector just 2 days ago. And I will talk about my tools at Black Hat Arsenal Europe this year. And also I'm a StarCraft 2 player, so if people like this game, come and we will we will speak about that after the conference. Why Power Memory? Because I wanted to create something with PowerShell and using Microsoft tools, but Microsoft tools which is signed by Microsoft, so associated with a certificate delivered by Microsoft. So it's very cool and yes, get a lot of money, but it doesn't work. So I did I took a lot of fun with that. The agenda, what is Power Memory, and then I will show you what Power Memory use. So the binaries. Actually, it is debugger. So the debugger of Microsoft, which is WinDBG and CDB for the command line tool. Then we will be a little more bit technical. And I will show you exactly what I do in memory and what byte I change. I will talk about Empire. I suppose people like you know about Empire, and I made a pull request for Power Memory into Empire and mitigations. So what is Power Memory? Power Memory is a Minesweeper solver. That's all, folks. Thank you. That's a troll. But it's true, and I will show you how we can solve it. I never play at this game, you know, with all this kind of bomb. I never played before, but the goal was to illustrate, to show how you can modify the memory directly during the execution of the operating system with a tool like a debugger and automate it. And so imagine some other scenarios like financial software or something like that. So with PowerShell and a Microsoft tool, and which is a debugger signed, Power Memory can do what you want into the user land, the kernel land, and Wonderland. So I have, you know, if you know Cheshire in Alice in the Wonderland, it's for that. So basically what I do with PowerShell, so the tool and the debugger, is sending and receiving text bytes. That's all. I don't use API. I let the debugger do for me. So all the call to the operating system will be done by this debugger. And with that, you can do everything you want on the operating system. So Power Memory is a userland attacker, as I said. You can get Windows password from the memory. It's not the same thing that Mimikatz, because Mimikatz will call the API. Here I just use the debugger. you can inject, execute a shell code in a remote process. You can modify the memory of a process. Then you can do kernel and stuff too. So you will have some screen like that. But it's very useful because you can do all what advanced malware can do. So, by example, DKOM for direct kernel object manipulation. And with this kind of techniques, you can hide a process from the task manager, by example, and from the kernel structures. You can protect a process, which is very interesting because it lets you access to special processes like LSASS. If you cannot see very well on the screen, but if you try on several recent operating system to dump this process, you will have this kind of error message. So by protecting your process as LSASS, you will be able to dump it as usual. You can inject all privilege in a process with system identity and just by sending bytes into the process, and then you will have all the operating right. I don't know all the right, it's pretty a lot, but I'm sure I have all the right, And you can pass the token attack. So they are all proof of concept, but you can do a lot more if you want. For memory, more of that is also an Active Directory recognition tool, so you can use it to make a scan in an Active Directory domain, and passive because it's with SPN technique, which is a service principal name in Active Directory. So if you want to have, I don't know, all the SQL server, you can do it by just asking to the domain controller. You can have a file server, everything you want. You can get GPP's password, but for all connected forests, so this tool will detect all the forest and forest connected, and will try to retrieve all the GPP password of all the domain and forest connected. So you can also assess the server shares of all connected forest, looking for share accessible for authenticated user, because it's often the case in a domain. So when it's not very well configured, you will have this kind of behavior on the network. So you can assess that, and you can draw the AD topology like in Visual, just for the fun. Also, you can try to elevate your rights, because if you are not an administrator on the workstation, you cannot do a lot of things. So you have PowerShell that can be launched and it will try to elevate your right on this workstation. It breaks the McAfee password, which are stored in XML files. So I did that with two person did that. I did the other way. You can provoke a BSOD, and why I did this proof of concept is because if the computer is configured to crash and dump the crash on the operating system, you can collect that crash and then give it to primary memory and get the passwords. Bypass USC, and something very funny on very old software that I saw in a different client. So it's actually, I think it's something in 94, something like that, and it's actually again installed on several clients. So it's interesting. So if you launch the tool directly on a computer, you will have a menu like that. And you can try all the things I just said. It's very easy to use. Okay, so what's debugger power memory use? It will lever the sentence of Jeff Resnover, who creates PowerShell. He said to us to automate all the things. So I said to myself, okay, I will automate something like the debugger to do things like that, so to abuse Windows, but you can do everything you want. As I said, why I wanted to use that? Because it's signed. And it's signed. So if never an antivirus will catch that by default, and I don't know a lot of use cases that were developed on SIM to detect that behavior, because if you have to try to detect all the signed binaries, it will be very difficult, but you have to do that because as I show you, it can be a big problem. So it's trusted everywhere. First step, when you are in front of the console of the debugger, you can ask him to display byte. So on the screen I put DB, and you will have the byte. So it's like 51D1, something like that. I don't know if you can see that. I'm not sure. So when you type that, you will have this kind of information. So you see just letter and numbers. You can do that, display words for display 2 bytes, display double words for 4 bytes, etc. And if you type DU, you will have the ASCII representation, so the clear text. I just type DU and an address in memory, and I get my email. So PA Bracken at blah blah blah. If you do that on a address where a password is contained, you will have something like not in the ASCII table, so you won't see anything. So you have to do other things to get the password. It's not as easy. Also, when you try to load, to display information, so when you compile a program, it will be, in all cases, it will generate a PDB file. And the PDB file contains some information very important for the program to run. And Microsoft is very cool with us because he hosts a special symbol server on the internet that you can access. And every developer will access to that to debug kernel things. So they host all the symbols that are generated with their programs. So if I just try to display something with a symbol, so it's W, digest, etc., and I didn't load the symbols, I will have quotation marks, so not the content of the content of the byte. If I load the symbols, I will have the bytes. I'm sorry that you cannot look very well at the screen. So the symbols are free. You can the slide will be on the internet, so you will be able to look at that more clearly. So symbol is free. You can really easily put that in the debugger, and it will manage all the things for you. You don't have to know nothing about symbols to load that. So you indicate this URL in your debugger, and you will be able to get all the symbols. So to get the password in the memory, you will need to have different symbols I will give you now. So the first one is the symbols which represent the list entry, because all the passwords in the memory are contained in a list, circular list, and so you will need to go through the list to get all the accounts that it's stored in memory. Because if you are on on a terminal server, which a lot of users, 10 users by example, you will need to get to all these 10 users to get all the passwords. So the first one is the list entry, and the symbol is L underscore, I don't know how to say that in English, but underscore, I don't know if it's correct, yeah? And log says list. Okay, so you type DB, these symbols, and you will get the bytes representing the first list entry. I will show you the list entry just after this slide. Then you will need the key, because the password is encrypted. It's a symmetrical encryption. You need these symbols, so I don't know, GEP, it's not very interesting, but DES, because NT5 is for 2003 operating system, or XP, by example. So the information are encrypted in DES, DESX, which is created by Microsoft and not documented. So it was very difficult to crack this one, and 2008, etc. So NT6, NTDIS was very easy because it's a standard protocol and feedback. And for NT6 and NT10, you need a DS key, so not DSX, and AES if it's encrypted into this protocol. But I never see the two protocols. I also see one, which is AES, and the initialization vector. But we need to go deeper now. So let's get technical, because it was, just easy, for now. So to really understand where to get the password, I will show you where it is. Yes, and it's not in kernel land, it's in user land, so it's you don't have to be into the kernel to do that. We will attack the digest security support provider, which is very interesting, because if you disable that, and Microsoft proposed as a solution to disable that in a company, you won't have SSO, so no SharePoint, no nothing. So nobody disable this feature, because if you disable that, your company won't work normally. How to do that? You steal the bytes. To steal the byte, you can dump LSAS process. You can do it locally or remotely, and my tool do it locally or remotely. You can convert a file like ibersys, iberfile.sys, excuse me, to dump the information. You can provoke a BSOD and get the crash dump file. So you are maybe not an administrator of the computer. You can lever the hypervisor, because imagine that you are an operator, not an administrator, an operator of VMware or Hyper-V, but you don't have no right on the target. So on the Windows installed into the hypervisor, as an operator, if I have the right to get special file which contains the memory of the virtual machine inside the hypervisor, I will get all the passwords. So I did it, and you can get the password as an operator in Hyper-V and in VMware. And Microsoft said to me, no, it's not a problem, because you are in front of the hypervisor. So, okay. You can also access LSAS process directly if you have kernel mode access. So if you have kernel mode access, you don't need to dump that. You can directly steal the bytes. Okay, so Power Memory, what it does, it calls the debugger, he sends to it a command to execute, then he retrieves the bytes, he parses them very basically. When he has them, okay, he needs something else, he begins another command to inject, and he launch it. And he can write to an address too, because of the debugger, thanks to the debugger. So, okay, can you see the password? The password is over there, I'll show you. But if I show that, it would be like I ask you to, where is Waldo, I don't know. I never found Waldo, because it's even more difficult on the screen, I think. I hope you will see that, because it's very interesting. So it's the list entry. I give you the symbols to get the list entry. So it's a list entry of a dump from a 2008 R2 Windows Server. Okay. The first green element is the next entry in the list. Okay, it's an address. You type this address, you will get the next entry in the list. The red one is the previous one, because it's circular, like I said. This address, so as you can see, it's this address. the LUID address, which is not at all interesting to get the password, but which is a unique identifier on a Windows computer, which is guaranteed to be unique until the next reboot. Then you have the username address, and it's in clear text. So if you type DU this address, you will have the username, the NetBIOS domain name address, the encrypted password. So if you try DU, you will get nothing. The domain name address and the username at domain address. So it's true for 2008 R2 on a 2064-bit architecture. If you have a 32-bit 2003, it will be different. If you have a 2010, it will be different. So I had to parse all the things regarding the operating system targeted. Max length of the field and min length for minimum. So you have the password, because you have the address of the password. It's not enough. You need the key and the initialization vector on the 2008 R2. So, okay, I type DD LSASRV exclamation mark and H3DES key, and I get this kind of thing. So the green address is the next entry. So, okay, I type that. I get, in red, I get the size of the block. It's empirical, so I figure it out, but I'm not sure it's the thing. But I review a lot of them, really, so I think it's the size. The tag KSSM, which is also always the same. Next information, you type this address, and you will get in red the size, in purple and another tag, which is MSSK, and the key. And if you type DB, it will be the little endian transformation for you. So it's interesting. So in blue, you have the key represented in byte for you. So you have the password, you have the key, you need the initialization vector, and there we will be very technical now to get that. It's very difficult to get that. You have to type DB and the symbol, and you have the directly the initialization vector. So it's a more difficult part of all the thing. So you have the three information. With this three information, you will be able to decrypt that very easily by a standard algorithm, nothing new. Okay, I have some demos. So first demo to get the password. Okay. So it's PowerShell. I see nothing. Okay. So you just launch it locally on the computer. It shows you a menu. You type, okay, I want the password. So I type 1. I figure it out your right level, etc. So it launch another console. And then you can do different things. The first thing is, okay, if you are into a Windows domain, do you want that, if I find something, do you want that I match it with, is it a domain administrator? Is it an enterprise one? Is it a backup operator? What is it? But if you do that, it will make a LDAP request into the domain controller. So maybe you don't want to do that. If you don't want, you type 2. To get the password locally, you type 1. You can do remotely. You can do from a LSAS process. You collect, I don't know, when you go to a friend house or something like that. You can do it with VM snapshot. You can do it in kernel mode. So I will type 1. And no, I don't want to send it to pastebin. But if you just type enter, it won't send it. I assure you. You can look into the code. I have nothing to hide. So okay. And do you want to I don't know. Do you want to clear event log on this computer? So yes, we can just the technique is just to stop everything that holds the event log. So I do that first, and that I replace the log with another log that contains nothing or information completely useless. So yes, getting valuable information, and okay, I have password, and I put a very secure one because I put 2, password 2. Because 1 is very insecure, so I prefer, And the non-understandable character is because it's a key associated with the machine, with the computer. Okay. Okay, you can inject a shellcode into a remote process and execute it. And the goal is not just to do what you can already do, but do it and never use an API. Okay? So just manipulating byte into the memory, and I would like to call it without call an API. So to do that, you need to get a memory executable zone somewhere. You need a null padding zone into this memory executable zone that you get, and you need the address of the null padding zone to execute it, because I give you the hint, to execute it we will just modify the register instruction pointer, and so the next instruction send it to the operating system will be your shellcode. So we will need to parse the portable executable, load it into the memory. And it's not very difficult. The first thing you have to get is the address of the module loaded into the memory. So for the target that you try to parse. From this module address, you get the PE header address, which is located from the module address you get plus 3C. From this PE address, which is always 24 bytes, you have the size of the optional header in bytes. From the optional header, you can have the section table structure, and you will, because it follows immediately the previous information you get. And from the section table, you will have the virtual size, the virtual address, and the raw data pointers that you need with to calculate your padding zone, etc. And then it is a command that so I write a byte. So I take a shellcode, I write the byte into the memory, and I just ask to the debugger to modify the register instruction pointer with the module address that I found, and it will launch my shellcode into the process that I attacked with the level of write of this process. And you will have a calculator. Demo. A friend of me pray actually the gods of demo, because I have like 4 demos, so okay. Okay. Oh yeah, I can show you the Minesweeper solver, because it shows something about modifying memory directly. I don't know, but if an accountant modify financial information into the memory, it could be very not secure, to see this data modify, and the accountant could see the things normally, and the data send it won't be the data he tried to input into the screen. So okay, so define the field. Oh. Okay, so it launched something. So it's the grid with all the you have to click, etc. So okay. Yeah, it's not easy. but maybe I will just for that modify my settings. Okay. So you have here, you have the Minesweeper, you have the menu, because he asks you, okay, how do you want to solve the grid of a Minesweeper? You can flag the bomb if you want, like the normal game, but it's very bad game. I don't like, put all the flag. It's not very interesting. You can demine the bombs directly if you want. You can reveal the bombs. You can explode the bombs and still win. You can make a 42 option, which is a special one, and you can clean the board. If I try, I don't know, to explode the bombs, so it works with my phone in stuttering, so maybe it won't be very quick, very fast. So it looks in the kernel, in the user land, so it's not kernel, and it will try to figure out which is the site of the grid, and then pass it into the memory, because into the memory you have the exact structures that you can see on the screen, but not exactly like the grid perfectly aligned. It's not like that. Normally it's very quick, but okay. So you show the icon here. Normally it has to work, it will work. It's just because the internet connection, I think, of my phone. Okay, so 13 times 16, so he saw the grid into the memory and he say, okay, has been secure. So I will try to display that. Oh, wow, interesting. So I have exploited all the mines, and I cannot lose now. So it's, okay, you can do that. It's not very interesting because it's not fast to win. So I prefer to select, the option of clean the board, and I just click one, and then I win directly, and I have the maximum score. Yeah. So it's fun, but the goal is to show you the impact. So for the rest, injection into a remote process. No, it's not better. So I will. Oh. Wow. Okay. I don't know if I have a process. Okay, I have a CMD. Okay, command prompt. I will close it. Okay, so I launch another one. So I want to inject something, not all the privilege, not for this time, but a process, something. So he pass all the things, and normally you have to see. I don't see that because why is that? Why is calculator? Okay. I don't know why it does not work. Okay. Okay. Actually it worked, but as we cannot see all the screen, I will try to just relaunch it. Sorry. Yes, I don't know why it is, but normally you see it. I can try to inject in, because in fact if I try to put exit, I don't exit because my process is already injected into. But if you want to see the calculator, I will try to inject another process like Notepad. Okay, I have the calculator. So, and if I show you into the memory with the tools of Mark Krusinovic working on Microsoft, and who create this internal suite, it's injected into the Notepad. Okay, the calculator is into the Notepad.exe process. Okay. Yes, but okay. Kernel stuff. So now we are going to the kernel land because it's more fun. You can do everything in kernel. All what you can do in userland, but also a lot of things that you cannot. And just to make a easy proof of concept that it's easy to understand, I will show you the hide process. It's not a new technique to hide a process. It's advanced malware already did that, but maybe not with a debugger and a PowerShell like that. So if you want to hide a process into the memory, a process is contained into a eProcess structure. If you type on Google eProcess structure, you will find it, and you have this kind of information. So each little square is a process, and yes, F-link B-link is forward link and backward link. You can see that all is linked to each other and in a circular way. So the first thing to do is to unlink, a process, because it's more fun if it's unlinked, because the kernel won't be able to see that. But if you just do that, it just BSOD. So it's blue screen of death immediately. So you have to give to the kernel the illusion all is okay. So, okay, in PowerShell, you send a command to the debugger, and you create this link from the previous process to the next one, and you do the things for the backward link. But if you do just that, same thing, BSOD, because the operating system will figure out that you have do something with its structure, its internal structure, because one of the process, which is actually process, is not linked to anything, so it's not normal. So you simulate it, you create that and this, and all will be very good for the kernel, and you can continue to work normally with a process which is hidden. So yes, sorry. So demo, right, yes, that up. So demo. You want to hide something to the kernel and to the operating system. Sorry. So okay, we have the CMD that we had just before. I will type hide my process, which is cmd.exe, and I will try to have. Okay. Okay. Maybe I will have the same problem with the internet connection, because why I need the internet connection? I don't really need it absolutely, but as I said, first I connect to Microsoft. Yes, he found the address. And he is not there. I have to connect to the Microsoft servers, Microsoft symbol servers, to get the symbols, and then be able to type all the things. I could preload all the symbols on my computer and don't need to do that, but I don't want to to put all the symbols of all the operating system of my computer, because it's not a targeted attack, it's a demonstration. If I need to make something targeted, I will target a specific operating system on a specific architecture. So yes, it's sorted by name, so yes, he's not there, but he's there, because if I yes, yes, I have CMD, I can type who am I, yes, like that. And yes, it works, because in Windows you have process and thread, and the thread continue to work normally. But I like to to do correctly things. So if you have this address, which is the current address of this process, Yes, it appears. So it works too. Okay. Yeah. I did a thing to weaponize these tools. So you can, if you know Empire, which is a very cool tool, I did a pull request on it, and to be able to do this kind of things with the debugger on the target. So it's not in Wonderland, it's the real world. So normally I have music with, you know, I don't know that. I don't have that for you, sorry. So Empire is a very cool tool. If you don't know that, you have to look at that on the internet. So it was developed by 3 people, but also helped by other people. So Armjom, Sixdup, and Enigma, but you have also Matt Grabber, which is a very awesome guy, and Shot Metcalf that spoke just before. So if you want to do that, you have to target something, I don't know what. You force the target to load your Empire agent, and through the Empire agent, you load power memory into the target memory. You drop the signed debugger because it's the concept, and you make funnel profits. And I have a demo for you. So you have a basic Kelly, and here maybe the password is not as secure as the other one because it's 1. So you have Empire. Okay, I have a listener but no agents. And you can do different things. Here I will try to show you something, but I'm not sure it will work. But it's something that Casey Smith, I don't know if you know him, Casey Smith, sub-T, he illustrates a different technique to whitelist, to try to bypass Microsoft Think with Microsoft Tools too. So he showed that with a software called msbuild.exe, you should be able to launch, I don't know, PowerShell code, by example. So as soon as I saw that, I tried to do something, and the thing is, yeah, okay. The thing is to launch PowerShell, but without having PowerShell into memory. Okay. So it's into okay. No, okay. And you have the framework here. So you have MS build, which is pre-installed by Microsoft. And I prepare something which is BSides DC.xml. So if you are able to force, by example, by something like a rule or a not lock rule or client rule, to force the client to launch a software which is already installed in the operating system with just something very not dangerous like an XML file, you should be able to provoke something like that. Okay, I have an agent. You saw? So initial agent, blah, blah, blah. It just comes from that. And if I check my memory, just with that, I see PowerShell eyes, which is my IDE, but I don't see PowerShell as a console, because if PowerShell was launched, I will have something like that. And it's actually loaded into msbuild.exe, so it's pretty cool. It's on my GitHub if you want to take a look at that. But the objective was not that, is to look at power memory through Empire, so you can interact with this agent, use a module, credential, and my tool is, it's really easy to say, it's RWMCRS, but it actually means something. It's to reveal Windows memory credential remote shell. So info, you don't need anything else that an active agent on your target, and you type run. Normally it will work. Yeah, so debug. So you have, I don't know, okay, follow the right rabbit, obviously, in Wonderland. And normally we will have a password. So you have this machine, yes, so password to, you know, etc. And this machine is maybe, I don't know, on the internet or something like that. Okay, mitigation. How to mitigate that kind of attacks? The first thing is to don't trust the trusted tools. Sorry, but it's the first answer to that. You have to look at their behavior, so it's it's more difficult. It's not just okay, this tool is not signed, because people say, okay, I will just take a look at all the, I don't know, autoruns, by example, which is installed on the operating system, and just look at those which is not signed. But yes, look also at those which is signed, because if you have a debugger on your autoruns, it may be a problem. You have to look for dumping activities. And Microsoft don't provide something to do that. You have to code it yourself. I did it. It's not on my GitHub yet, but maybe I will. It's really simple. You have to try to detect if something is being to attack. No, to suspend. Okay, the process, because when you try to dump a process, you will see a very quick suspend state on this process. So if you are able to detect that a process is suspended, it's not very normal on something like LSAS. You have to look for bcdedit.exe use. Why? Because these tools, which is tools, Microsoft tools, and which is installed on your computer, is allow an attacker, if the computer is not protected by BIOS or something like that, to launch your computers next time in kernel mode. And a way to detect if your computer is in kernel mode is to try to take a screenshot. If you do that, you will provoke a break, you know, in the kernel. So it will just do something like that. Don't trust the endpoint, it's not new, and look for behavior. And yes, I work at Deloitte. I don't know if I already said that, but we have a methodology, so being secure, vigilant, and resilient. And the major point is, the first thing is you have to know your crown jewels, and it's to to link with behavior. So if you know what are your crown jewels, you will be able to protect this information. And you have different steps that you could read on this slide, and that you can read after. We do actually a lot of things. So we make red team, we make compromise assessment, and we also do things like architecture, and so all the loop is taken in account. And yes, something that we said a lot is if you have a company, you will be hacked. The goal is not to avoid all the attacks, but to be able to respond to that. So maybe have, I don't know, an incident response program develop into your company. And if you don't have that, you need maybe to put it in place. Other thing, the summary. So per memory levels PowerShell and assigned Microsoft debugger to hack Microsoft operating system. It's difficult to detect because it just sends text and bytes to the debugger. So if you look at the activity, it's not very obvious, to detect, oh, it just sent 0, 1, and then it just sent AF, I don't know. So, you know, if you see that, it won't be very easy to detect. You can also make reconnaissance, I don't know how to say that, of an Active Directory domain. And you can also try to escalate on a workstation and endpoint. Thank you very much.